In this video, we're going to solve a particular problem which appeared in JEE Advanced 2014. Here, we have given a function f and g in the form of x mod of x plus 1 and mod of x, gx as x squared plus 1. And we need to find out, right, that how many points the function hx is not differentiable, where hx is defined in some typical form, right? Max and mean between fx and gx. So that means we need to find out, right, between fx and gx, which is actually the larger value or which is actually lies above the another function, right? That's it. Now, this particular problem will solve pictorially. Let's go ahead and solve it. Now, let's proceed. Now, to solve this particular problem, right, we'll use the graphical approach first. Why? Because for graphical approach, it is easy to understand, right, that which graph lies above or below or the other graph, right? So first we need to concentrate on the function fx and gx. So do so, right? Here we consider the function fx and consider the function gx. Now here we have to make a small observation. We note that, right, if x lies between -1 to 1, right, that means x belongs to in the open interval -1 to 1, then mod x is actually have larger value than x squared, right? Because that's the fundamental properties of squaring, right? If the value is small, that between 1, the value is less than that, right? That's it. So therefore, that's one. And for if x doesn't belongs to that -1 to 1, x squared will be greater than x. And that means the relation between gx and fx will be gx less than fx and gx greater than fx on that. But that's not all. It may be something else. So that's why we will go ahead and do the sketching. Now we note that, right, that the function fx, which is equal to mod x plus 1. Now when x is greater than 0, it will be equal to x plus 1. When it's less than 0, it will be minus x plus 1. Direct application or direct use of the modulus function. Now, for point of intersection, that how many points these two curves fx and gx intersect, we consider fx equal to gx. So therefore, when we consider x greater than 0, fx will be x plus 1, which is equal to x squared plus 1. That's why x is equal to 0 and 1 are the point of intersection. And that particular x equal to 0, f0 will be obviously 1 and 2. So therefore, 0, 1 and 1, 2 are the point of intersection. And when x is less than 0, it will be minus x plus 1 equal to x squared plus 1. And hence, it will be x squared plus x is equal to 0. But here, only the solution is x plus 1 equal to 0. Why? Because x cannot be 0 because our domain of interest is x less than 0. So therefore, the roots are x equal to -1 and hence f of -1 at that particular point will be 2. So therefore, we'll say that the point of intersection are -1, 2, 0, 1 and 1, 2. That's it. So now we need to go ahead and sketch. So first we sketch the function mod x. So that's why we draw x-axis, so y-axis, and we draw the mod x function, which is a very trivial function. But here we need to draw the function fx equal to mod x plus 1. So that's why every point on mod x will be lifted 1 unit upwards. So therefore, if we do so, we'll get, right, the function which is fx. That's it. Now we need to concentrate on gx, which is a parabola opening upwards. Why? Because the coefficient of x squared is positive and it will be form of y minus 1 is equal to x squared, right? So therefore, we can say that it will be in the form of a parabola, right? Y minus 1 is equal to x squared. So therefore, where the vertex is actually at the point 1, 0. Okay, that's it. So let's try to sketch the parabola, stating that, right, that when it lies between -1 to 1, right, our parabola will be lies below the fx curve and afterwards it will increase, right? So that's the phenomena. So that's why that analysis we done earlier. So if we draw the parabola, we able to draw it. Now, as based on the point of intersection, we also able to mark all those point of intersection, all those important equation of the curve, and that's it. So therefore, notice that when x is less than 0, it is minus x plus 1. So the equation of the line, when x greater than 1, this is the equation of the line, and gx is equal to x squared plus 1. And that's it. Now we consider the given function hx. Now what it says? It says that when x is less than 0, okay, that we have to write down the maximum value of fx and gx. So see that if I go ahead from minus infinity to minus 1, what is the maximum curve? This is the blue curve. So that is gx, right? So therefore we'll say that, right, that when x lies between minus infinity to minus 1, then hx is equal to gx, right? And therefore hx is equal to x squared plus 1. So this is the curve. Now, when it lies between minus 1 to 0, which is the largest? You see the yellow thing. That means the straight line is the contain the higher value. So therefore, when it lies between minus 1 to 0, hx is equal to fx, and then hx is equal to minus x plus 1. Now go ahead and take 0 to 1 interval. In that interval, our definition says we need to take the minimum value. So minimum means the lower curve. What is the lower curve? Is gx. So therefore, it will be gx and it will be x squared plus 1. And in the last interval 1 to infinity, what is the lower curve? The straight line. So therefore, we'll say that it will be fx and x plus 1. So now see that in different interval, we are able to identify all the different definition of the function hx. So now let's collect all those information. We need to find out how many points that differentiable function hx is not differentiable. So notice that by the plot, right, it is a continuous function, right? No doubt about it. But is it derivative exist here, right? That we need to test it. By seeing that here by approximate sketch, right, I can easily conclude that the function doesn't have derivative, right, at any point. Why? You can see that, right? That uh, that we have two tangent at every point. Okay, so that's why we can say that it's not exist. But direct observation is not the mathematical approach. So that's why we just go ahead. So here we just differentiate the function hx, right, in the each and every small interval. We are not saying that we are doing the differentiation at the juncture, right? That point minus 1, 0, and 1. We can't do that because that need to be analyzed. But we can do it for when it is lies inside that interval. So if I do that, h dash x will be 2x, h dash x for the next case will be minus 1, then 2x, and then 1 itself, right? So let's go ahead. So what happened? I just note down the differentiation here. So it is 2x, then it will be minus 1, then it will be again 2x, and then it will be again 1. Now notice that, right, that at minus 1 plus minus something and plus something, right, in these values, right, whenever I put 1 minus something, we have to go ahead with this definition. So therefore it will be minus 2, and whenever I go minus 1 plus something, we have to substitute it in this expression, so it will be minus 1. So therefore we can say that if dash of h dash of minus 1, for that we need to substitute it here. We get minus 2. For that case, it will be minus 1. So the right and left derivative at the point minus 1 are not equal. So therefore, derivative doesn't exist. Similarly, at 0, right, it will be minus 1. And if I substitute in the next case for h0 plus, right, it will give you 0. So again, the derivative doesn't exist here. If we go ahead and put the one value in this 2x and to calculate the left and right derivative, we'll get it as 2x and 1. So basically what happened? It is x squared plus 1. So therefore, we can draw a 2x, right? So this is a curve of 2x, right? So this is a straight line. Then we have minus 1. Minus 1 means that it is minus 1. Then again, it will be 2x. And then it will be plus 1. So this will be the plot of h dash x. Now you can easily see that h dash x is not continuous, right, in this interval. And that's why we can say that h dash x is not exist at this particular point. That means hx is not differentiable at the point -1, 0, and 1. And that's why we have 3 point exists so that hx is not differentiable. And that's it. So see that by the use of little bit of sketching, we solve the advanced level problem. And here we explained it, so that's why it takes some time. But you can see that, right? That drawing doesn't take much time. And if you know how to sketch it, okay, so then this particular problem can be solved in only less than a minute. And that's it. Hope you understood the problem. Thank you.